Hey guys, so today is Tuesday, March 31st. Look, yesterday's notes were pretty heavy as far as new content, so the goal for today is to give you just a recap of the notes and try to make it a little bit easier, a little more simplified. So, yesterday's note was the idea of a discriminant, and a discriminant is a numerical value that you can compute using b squared minus 4ac. Now, this result, this number, will give us two different things about our quadratic. For today, we're going to focus on just can we factor a quadratic given the discriminant? That's all we're going to come out today. Just focus on this. Now, before we start with examples, why do we even check the discriminant first? Because it tells us if we can factor. Now, if we cannot factor a quadratic, we're going to have other approaches to solve them in the next several weeks. So to not waste time trying to see if we can factor, the discriminant will give us that from the very beginning, and we then go from there. With that, to start examples A, B, and C, let's find the discriminant. If it's going to be a perfect square, then you can factor the given quadratic. Example A. So remember, it's b squared minus 4ac to compute the discriminant. And in this case, let's identify A here is 1. So A is 1, B is 10, and C is 25. So it's b squared, so 10 squared, minus 4a. A happens to be 1 here, so A is 1. And then C is 25, which goes there. And that's kind of it. That's how the discriminant works. Now with the calculator, you can kind of compute this out and get that 10 squared is 100. And then negative 4 times 1 is negative 4. Times 25 more is negative 100. And so to finish the discriminant, 100 minus 100 is equal to 0. And because 0 is a perfect square of 0 times 0, so since the result of my discriminant is a perfect square, then I know, yes, this question is factorable. So that's what I care about for today in regards to the discriminant, that I can identify this result. Okay, with that, pause the video, try examples B and C, and find the discriminant and see what you come up with. And when you come back and hit play, I'll have the answers worked out for you on the screen. Alright guys, so coming back now to examples B and C. Notice how first off, example B, in this quadratic expression, you're missing your C term from the beginning, so when that happens, it's because C is 0. So that's okay, just fill it in yourself. So then b squared minus 4ac gives us 16 minus 4 once you compute it, which is 12. Because the discriminant here is 12, and 12 is not a perfect square, this quadratic here is not factorable. Now going to example C, again identifying my A, B, and C values, applying the discriminant, I end up getting that it's going to be 41. Again, because 41 here also, actually guys, I made a mistake. Sorry guys, I'm also getting back into routine here. Go back to example B for a second. There's a 0 here, so 0 times anything is 0, and I put a 4 there by accident. So let's fix that real quick here. So this actually is not going to work out the way I first said it. This would be a 0. So 0 times 4 and 1 basically is 0, so that should be a 0 instead of what I said originally. And then 16 minus 0 is 16. So here, let me correct myself, 16 is a perfect square. So in example B, because the discriminant is a perfect square, this one will be factorable. This one would work out for us. But going back to example C, in this case, doing the discriminant, I get a 41. 41 is not a perfect square, so that's not factorable. So to summarize, the discriminant is just a number that we can calculate, and it'll tell us if we can factor our quadratic. With that, the goal for today's practice is to do more factoring. And so here are your steps again. There's 5 of them. Let's go through some examples here and just practice factoring quadratics by grouping. But first, find the discriminant to see if we can even factor to begin with. Alright guys, so I'm going to show you example D. You'll try E. Then I'll show you F. And at that point, examples G, H, and I will be for you to practice on your own to finish today's lesson. So, example D. First, let's identify A, B, and C. So A here is 1, B is negative 16, and C is 60. let's find the discriminant. So b squared minus 4ac. So that's going to be negative 16. So b squared minus 4ac. That's a 60. So with that I get 16 squared is going to be 256. And then negative 4 times 60 is negative 240. And I'm working that out. Again, you guys have calculators. I get 16. Because 16 is a perfect square, I know that I can factor this quadratic. So at that point, I'll move forward with the question. So next, let's go and x factor this. And going through my steps from above, up here is a times c. So in this case, it's 1 times 60. Then down here is my b value, so it's negative 16. Then making a list of all of my factors of 60, which there are a bunch. It's 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. So those all make 60. Which of them do you think can combine to make 16? And I'm looking at 6 and 10. So I'm going to choose those two to insert into my x factor organizer. And to make these combine to be a negative 16, I'm going to make them both negative in this case. So if I make them both negative, let's check. Negative 6 times negative 10, that's equal to negative 60. Sorry, to positive 60. So that's what I have up here. So that works out. So that's a check. At the same time, minus 6 minus 10 is negative 16. That also verifies what I have here, so this one is good to go. It works. So remember, the whole point of this process here is to simply split the original b value. So writing the equation here on this side, the original problem, I can now split the b term into two equivalent values, namely negative 6 and negative 10. So negative 6x and negative 10x. The x squared here and the plus 60 on the back end are still going to be there in the problem. I simply just split this into two equivalent terms. To finish this process, I'm going to now group, factor by grouping, and finding GCF 3 times. So here's my two groups, and I'll GCF 3 times. First, what do these two terms have in common? They have an x in common. So that comes out of those two terms, leaving with x minus 6. Looking at the second little group, they have, in this case, a minus 10 in common. So I can divide minus 10 out of both of them. So I'll put that here. And in doing so, I get x, and then 60 divided by negative 10 is negative 6. So x minus 6. And guys, remember how we said for this process to work, as we factor, these have to be the same. Or else I made a mistake somewhere, and they are the same. So to finish, I can look at now what's left in my process, and I can take out from these two pieces the x minus 6, which they both have, and then the x minus 10, which is here and here, and I get my factored form. So this is the factored form of my original problem, way up here on top. Now, this is a lot of work. As you get faster, you can do it much quicker than I'm doing now. I'm showing you every single little step to start, but you'll get faster at this as you get better at it. So go ahead and pause the video and please try example E. Alright guys, so here's example E. So going through all the work, here's my discriminant. It's 81, so it's a perfect square, so I know I can move forward and factor. As I factor this question out, I do all my work here. I'm going to just zoom through it here. Notice as I GCF this 3 times, at this point of the question, I expect that this and this should be the exact same thing. So in here, in this case, x minus 1, it becomes one of my factors, and then x minus 10 is my other factor. So this is now my factored form. I factored this question, where x minus 1 is a factor, x minus 10 is a factor. Guys, at this point, go ahead and pause the video and please try F, G, H, and I. They're just 4 more examples. When you come back to the video, I'm going to show you example F fully explained, and then G, H, and I will just pop up with answers. And with that, we'll have 2 more days to practice this idea. It's not easy. It takes time to feel good about this process. So we'll give you time and watch the video again if you have to, and we'll go slow. Okay, so go ahead and pause the video, try the next 4 examples, come back and you can see the answers. Alright guys, so welcome back. Hopefully you try some of these on your own, at least F and G. Now, briefly with example F, again, notice how A is 2, B is 11, C is 14. So the first thing to do is the discriminant, B squared minus 4AC. So with the calculator I plugged it in, I get 9. Since 9 is a perfect square, I can continue and factor this question out. As I do that, here's my x factors. Remember, this is A times C, so 2 times 14 is 28. This would be my B number, which is 11 in this case. And then I go through and I find out how to finish this puzzle. So here 4 and 7 work. 4 times 7 is 28. 4 plus 7 is 11. The whole point of this process is to split your original B value of 11 into an equivalent 4 plus 7. And then I GCF this after I group it. Notice how at this point, this and this are the same. I have the same factors. So to finish this question off, I can go and I can take x plus 2 here. So I'll come here to the left, x plus 2, which is my shared factor. And then 2x plus 7. So this is the answer to example F. I factored this quadratic. Here are my 2 factors. X plus 2 is a factor. 2x plus 7 is another factor. Now with that, since we're on the screen, let's talk about G just briefly. Again, going through the same process of the discriminant. Here it's 16, so that's a perfect square, so I can proceed. And when I get down to the answer here, notice how again I have a common factor, so I'll take that out of the problem and my third GCF. So that's taken out of each. And then I have an x plus 2 left over. So this is the factored form of example G. Guys, with that, pause the video, and again for the next examples, just try them out. To repeat, this is not easy. It looks very scary, probably if you see the whole thing worked out in the blink of an eye. But it is a process that you can follow, and you'll get better at it as we go over it over the next several days and into next week. Okay, so pause it and please try H and I. Alright guys, so here's examples H and I. So notice how here I'm a little bit faster by not writing the original question again as I went through my process. I just split the bx term here from the x factor to the next step. And again, just as another observation, as you're going through this, remember that as you're going through the factoring process, these need to be the same. Notice how you'll see that every time, and they become one of your factors as you finish up the process. So with that, this is the end of this video, guys. Again, tomorrow will be, in fact, Wednesday and Thursday will be just more practicing of factoring and getting better and faster at this process. Guys, stay safe, and we'll see you tomorrow. Take care. Bye-bye.